What kind of work have we done? Solving it how? Completing the square. What else have we done? Good job. Factoring. Good job. What? And then we did something else with some quadratics. We solved. That's exactly what I wanted you to get to, Jackson. I want you to get to. Good job. Good job. Everything that we have done so far has been to solve the quadratic to find the zeros. Tell me graphically what's a zero.
An X on the x-axis.
That's you are on fire today. Zeros. Oh my gosh. All right, so when we have a quadratic, let's say I have x squared plus 5x plus 6, right? And when we factored it, we grouped it. What multiplies to 6 but adds to 5? 3 and 2, right? That's okay. And we talked about if this was y equals, so it was graphed, right? If I wanted to find the zeros, then I would change that y to a 0. Continue to factor it. And I'm running through this really quick because this is kind of review, but it's going to tie into what we're doing today. And now, come on. What are the zeros of the function? Where does it cross the x? -2 and -3, right? That's where it crosses the x-axis. So I don't know anything else, but I do know that it crosses at -2 and -3. Now tell me, when you graph a quadratic, what does it look like? A parabola. You're exactly right. It looks like a parabola. So it's going to look like this, but I know that this is -3 and this is not -3 again, -2. Okay, so far that's what I know about it, and I know that that's how I find the zeros, right? Okay, so today we're actually going to graph that quadratic. If I start out with x squared plus 5x plus 6, we're going to graph it. Do y'all remember graphing that? Oh.
Excuse interruption. I need.
So let's graph some of these and let's find the zeros here, because this will be how we solve graphically. If we can find those places where they cross, then we know what x equals when the equation equals 0, right? Right. Those, yes. All right, so there's 3 forms that we graph in. I hope you remember this from Algebra 2. Do you remember graphing?
Yeah.
We're going to start with the hardest one, though. What's the one stapled on front of your notes? Standard form. It's the form that we factor in. Y'all are saying intercept. Intercept is just factored form. That's all it is. And then, yes, there's vertex. But this is standard. So before we actually graph, tell me some things about a parabola when you graph it. What do you know? Okay, that's assuming the A is 1.
Yeah, it's 1, but if it's 2,
That's, yeah. What else do you... Tell me some characteristics of the parabola itself. Oh, come on now. It only has 2 points. It has... How about it can open... What determines which way it opens? The negative or the positive what? Close. Somebody said it. Okay. If A is positive, it's happy. It's smiling. It opens up. If A is negative, it's sad. And it opens down. What else do you know? Say again? Skinny and big. That's right. It can be really, really skinny, or it can open up really wide depending on that value of A. What else do you know? What is this? Somebody said it, I think. That's not the vertex. What is it? Does anybody know? Y'all don't remember? It's the y-intercept. The x-intercepts, remember, are the solutions, but the y-intercept where it crosses the y-axis. Close. That, with the little dot thing, is the axis of symmetry. What is the axis of symmetry? And we know it's an axis of symmetry because our parabola is symmetric.
Ninth grader with the...
Okay. So what point, Chandler, here's what you were looking for. What point does the axis of symmetry go through? The vertex. The vertex is a very, very important point. One other little thing before we actually graph, just to make your graphing a little easier in standard form and in any form really. If it is symmetric, that means that if that yellow line was a mirror right there in the middle, it would reflect those points over, right? So it's the same distance to that line of symmetry on both sides. Okay? All right. Let's graph. I've got you steps here to graph in standard form. The steps are on the front, and then on the back there are several examples that we are going to go through together. So I'm going to run through the example on the back. You can follow along whichever you want. But looking at the equation, tell me before we even graph that quadratic, what do you know about it? It's going to be down. How do you know? The A is negative, right? It's negative out front. It's going to be down. What else do you know? The back of the first page, standard form. On standard form, the first page?
Yeah.
No, up one, the example. Yeah. What else do you know?
It's a negative A.
So it's going down. Yep, we said that. What else? Give me something else. Give me something else. That's all right. I appreciate the enthusiasm. And anybody tell me what you see?
I think it's going to be like what you
It's going to be average. But what else do you know? Something about the 7. What about the 7? It's the y-intercept. The y-intercept is 7. I know it's going to cross the y-axis at 7. All right, let's graph. First step. Just like with factoring, what is A? What's B? C is? All right, Jerome and Chandler know. I hope the rest of us know. First thing we want to do is find the vertex. Now here's where you have to remember a little formula. To find the vertex. Vertex is a point in a plane, right? So it has an X and it has a Y. We're going to first find the X, then we'll find the Y. I know I'm going a little fast through this. If I need to slow down, tell me. But this should be review for you. But if not, I'm happy to slow down. All right. Opposite B over 2A. I say opposite B and not negative B because if it's already negative, it's going to become positive. And if it's positive, it's going to become negative. So looking at our A, B, and our C, what is the X part of our vertex? Two over what? Two over negative 2, which is what? Negative 1. The X part of our vertex is negative 1, which means that that axis of symmetry is going to be at negative 1. Okay? There's negative 1. How about the Y part? How do you find Y if you have X? Look at the yellow equation. It's telling you Y equals negative X squared minus 2X plus 7. So if I want to know what Y equals, plug negative 1 in for X. Okay? Now be careful because there's lots of negatives in here, all right? This negative sits outside like this. So I got negative, then I have negative 1 squared minus 2 times negative 1 plus 7. Order of operations, say square it first. So this negative is still outside, and negative 1 squared is 1. Minus negative 2 plus 7. What does that give you? Y'all can do this. What's negative 1 plus 2 plus 7? Negative 1, 8. Okay.
No, I thought it was not a negative 1.
That's okay. That's all right. Thank you, Jackson. I appreciate you participating in the conversation. All right, I got negative 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, here's where different teachers teach this different ways, okay? Some of them tell you to apply the value of A and go from there. I like for you to plug in a point, to pick a point, an easy point, a point close to where your vertex sits, okay? So think about my vertex sits at x equals -1. What's super close to -1 that would be easy to work with? 0. I would say for my easy point, you'd get the same value if you did -2 and either one works. I would say 0 is the easiest here, okay? Because whenever I plug that back in, I get what? Yes, 7. 0 minus 0 plus 7. All right, so I'm going to put a 0, 7. Now, because I know that this parabola is symmetric, and it's symmetric about that yellow dashed line right there, how could I find another point in the parabola without doing any calculations? That's right. Reflect it over that line. Remember geometry, reflecting points? Here's what I do. Count over to this line. Count over that many more. That's all you need to graph a parabola. 3 points is good, as long as one of those 3 is the vertex. And the other 2 are on either side of it. Standard form. Okay. If I kept it going, I could find where it intersected the x-axis, and that would tell me the zeros also. Okay. Right now we'll focus on graphing before we actually get into finding those zeros. All right, that's standard form. Looking at example 2, and for the sake of time, I won't work through that one with you step by step. But looking at example 2, what is your A? 1/2. What is B? What is C? Ooh, 0. Tell me what that tells you. Tell me what you know. It's going to be up. It's going to be up because it's positive in front, right? Yep. It's going to be kind of wide because of the 1/2. What else do you know?
It's going to be on what's the middle?
Origin. It's going to have a point on the origin. That's exactly right. How do you know that, Jackson?
0.
Because that 0. The y-intercept is 0 there. Good job, y'all. All right. Some of yours might be in a different order, but let's look at intercept form. Okay, that's one. It should say 1, 2, intercept form at the top. Intercept form is really just factored form. And if you think about this, intercept form, I'm going to give it to you with the variables so that you can see. If you think about it, it makes sense, okay? A out front is the GCF that you took out before you started factoring. Here's your factored form. Factored form is what we use to solve, right? Didn't we say we use that to solve once we factor it? Remember that x squared plus 5x plus 6? What did you tell me, going back to the very beginning of the notes, the zeros were for that function? Where did it cross the x-axis? -3, -2, right? When we factored it, it was x plus 2, x plus 3. This is intercept form for that reason. It gives you the intercepts. Look at the connection here. Oh, I should have wrote them under the right one. Huh. Okay. Do you see the connection? Okay. The P and the Q are the x-intercepts. This is where they're crossing the x-axis. So before you even graph it, you know where it's going to cross x. Okay. This one doesn't give you the y, but it does give you the x. All right, so look at the example on the back of that page. A is still the same, and it still tells me opens up or down. Tell me what you know.
Going up.
It's going up. Why, Jackson? It's positive. What else do you know? I don't know the y-intercept, but I do know x-intercepts. What are the x-intercepts? -3 and 1. Good job. Don't forget to change the sign. I know. When you find, because remember, what you really do is you set those pieces equal to 0 and you solve, and when you solve, you have to move it to the other side. In other words, if I said x plus 3 equals 0,
Teachers, please send any student
I would have to
in
change
the
the sign to get it to the
ninth
other
grade with the
side.
last
So that's
name
why.
A through D to the auditorium at this time for pictures.
My poor recording.
That's students 9th grade, A through D.
All right. And we'll wrap this up shortly. I'm going to do this one and one other type, and then I'm going to set you loose on your work. So we're interrupted 1,000 times anyway. All right. -3 and 1. That tells me my x-intercepts, yes? Okay. So let's think about that on a graph. Here's 1. Here's -3. What do you know about a parabola shape-wise? It's a U. What else do you know about it? Geometrically shape-wise. It's symmetric, okay? So if I've got 2 points on that same line, then that axis of symmetry that divides it has to fall directly in between the 2 of those points, right? And these steps, y'all, are written on the directions there on the page before if you want to go back and look. All right, so to find the vertex, first thing I'm going to do is the axis of symmetry. Axis of symmetry. I'm going to take my 2 x's after you change the sign. And I'm going to, how do you find in the middle of 2 points? We did this back in the first part of this chapter. That's exactly right. You add and divide by 2. So I'm going to say -3 plus 1 divided by 2. What's that give you? -2 over 2, which is, do we all agree that -1 falls exactly in the middle of those 2 points? Absolutely it does. How could I find the y value on that axis of symmetry to know where to plot the vertex? Somebody said it. Plug it in. Plug it in that equation. So I'm going to say y equals 2 times -1 plus 3, -1 minus 1. Nope, that's +2, and that's -2. You're exactly right, it equals -8. So what is my vertex? -1, -8. I have enough points because I have a vertex and I have at least 1 point on either side of the vertex, and that is all I need to connect to make my parabola. Yeah. Those are coming from the original equation. That's coming from these. That's these 2 numbers. Which -1 in front? Right here? Right here? Yes, that's where I just plugged in for this x. That's it. Always. I started out with the hardest form. A little bit easier. I saved the easiest for last. Okay? Keep in mind, if it's in parentheses, change the sign. That's going to be the key with graphing on these, okay? Are y'all remembering this? Is it coming back to you a little bit? Some of you are staring at me like, what the heck are you talking about? And others are like, I'm so bored because I remember how to do this. Well, I'm not really teaching it, I'm just kind of refreshing you. So if you need me to delve deeper, you need to tell me and speak up, okay? Otherwise, I'm going to assume you remember. This is algebra 2. All right. Vertex form is easy, or intercept form is easy? H and K. Oh, yeah, H and K is really easy. All right, so the last form is vertex form. And if you can do standard form even some of the way, vertex form is a cinch.
What are these?
If I had to guess, you struggled with standard form and finding that intercept. I mean that vertex. Or intercept form where you had to average them together. Yeah. So I wanted you to have a resource here where you could go back and you could use this for any form, so you go back and go, God, I just don't remember how to do, and so you got this, you can go back and look at, okay? You're welcome, Chandler, you're so welcome. All right, let me give you the example that's on the back here. I promise I'm almost done. What time do we get done today? 9:40? 50?
You always be surprised like we have it.
Why can't I remember? I know. Because I just teach. I just teach. I don't know. Okay. Yes, that's on the recording. Yes, I just teach. That's what I do. Okay. Let me give you an example. 1/2 x plus 2 squared plus 5. This is called vertex form because, surprise, it gives you the what? Vertex. So HK is my vertex. So looking at this example, well, before I do my vertex, tell me what you know about the parabola. Quadratic. Opens up. It's going to be big. Oh. Oh, I didn't copy the negative from your example. You're right. Sorry. I apologize. Okay. So it's going down. It's going to be wide because of the 1/2. And that's really all I know at this point, right? Okay. What is my vertex here? -2, 5. Okay. Think standard form. Think first step is done for me. The vertex has already been found. -2, 1, 2, 3, 4, 5. Hamden, that is definitely not your calculator this time. Put that away, please. All right, -2, 5 vertex, yes? How many points do I need to graph a quadratic? 3. Okay. So go back to standard form. What do you do when you've got just the vertex? What's your next step? Easy point. That's exactly right. Easy point. What point is close to this that's pretty easy? You could use 0. I'll tell you, as you get further away from the vertex, the numbers get really big or really small really fast. I tend to try to stick 1 beside the vertex. You don't have to. So if you use 0, it's not wrong. I would probably go with -1 here. Well, standard form 0 is the easiest because that's the y-intercept. Oh, did I use 0? Oh. Okay. 0 is what the example on your paper. I'm going to use -1 here. Either one's fine, though. It really is. It really is. All right, plug it in. I feel like I'm talking fast today. So I'm trying to get through it. I'm not? Okay, thank you. Thank you for the vote of confidence there. I appreciate it. Okay, whoa. Well, in this case, that's my easy point. I just picked a random x. You can use whatever you want there. That's right. What? Is it? I don't know. 1/2 times. Jerome is on it. He's already figured it out. That's 1 squared plus 5. 4.5. -1/2 plus 5. Bless you. Now what? This is my favorite step. Just flip it. I call it reflect and connect. Isn't that catchy? Come on, Hamden. Reflect, connect. Yes or no on the 3 forms? Yes. Okay. Good. Those would be my zeros. Those would be the solutions where it crosses. Or this too. Here's another because they're whining about their homework. Here's the first one on the homework. Find your vertex. How you find your vertex, Silas?
Opposite B over 2A.
Opposite B over 2A. So it'll be 1. That's my axis of symmetry also. So if you want to go ahead and draw a dashed line through 1 up and down, you can. That's your axis of symmetry. That's the x part of your vertex. Tell me what you do now. Plug it back in. If you ever have an X and you don't have a Y, your answer is always plug it back in. Okay? Y equals -2. 1 squared. 4 times 1. What's -2 times 1 squared? -2. Plus 4. 2. So that means go up. There's your vertex, yes?
Any ninth grade student with the last name E through G should report to the auditorium at this time for pictures. That's the last name E through G ninth graders.
So the point is going to be a long one. So the point, yes, you take that first part, which is 1, and so it's 1, 2. Josue, what are you doing? Good Lord.
Oh, that's the lightest one.
Jesus be a fence. What?
That's the little thing we get.
I know. We're over here graphing quadratics and he's got kaleidoscope. Okay, that's geometry. Nice save. I appreciate you trying to save him. All right, I need an easy point. 0. 0. I would definitely use 0. As long as your vertex sitting on 0, you can use 0. If you plug 0 into that equation, what do you get back out? -2. Jerome.
I just guessed.
Jerome. What do you get? You thought that was C. You thought that was your C. That's why. And then you reflect and connect. Absolutely. It's 0, 0. Yep. Because we picked 0 because it was really close to 1.
Who said 11?
None of them are as hard as y'all make them. That's the point that I'm getting at.
From the 21.
Yes.
All
All right, pick one on 1, 2, and I'll do that one. Then I'm done.
right, hold on. You pick this one though. All right, you need to do. You said 4 through what?
4 through 15. All right, 4 through 9 is vertex, and 10 through 15 is intercept. Do 15. 15 doesn't look like intercept.
That's how they get you.
That's how they get you. 11 on the first page. And this is number 15 on the second page.
Oh, practice B?
Yep. Would you agree? And this is the only one you have like this. Would you agree that that's the same thing?
Yeah. Because it's still 7.
I can add 0 to anything, right? Sure, that's the same thing. So what's this form? Are you going to wake them up? Intercept. Intercept, 2 parentheses, intercepts. What are my 2 intercepts?
0 and -7.
Good job. Yes, hope. 0 and -7.
Okay.
They're going by 6. Yeah, they're using the units of 6 on your graph. What do I need to do now? You tell me and I'll do it. You got to find the line of symmetry. How do you find the line of symmetry? Yes, you do, Jackson. Yes, you do.
Oh, you got to plug in the X.
Plug it in where? Where does the line of symmetry happen when you got 2 points like that? Is it, how do you find in the middle? Okay, well, if you can't just look, what do you do? How do you find the middle of 2 points?
Oh, you add them
Add them and divide them by 2.
Add them and divide it by 2.
in the bottom. I said 3 to a point divided by 2.
Y'all like decimals better than fractions. Now what?
Plug it in.
That's right. If you ever find yourself with an X and you need a Y, you always go back and plug in. You will need your calculator for this. I would anyway.
What is that?
What is what? Where?
X equals what? 0 plus 7. 0 plus negative 7.
Yeah. You can go back to your original equation if you want, or you can go to the one where we did x plus 0, whichever you prefer. I don't know why I can't see my bottom screen down here now to get to my calculator. Someone with a calculator, by the way, this is going to come up to be positive 3.5. Somebody with a calculator do negative 3 times negative 3.5 times positive 3.5. Not everybody at once now.
Okay, so that's a positive.
36.
Negative 3.5 plus 7 gives you positive 3.5.
Oh, that says equals.
Oh, I'm sorry. 36 point what? Positive? Okay, so look, your y-axis is going by 6s. So go up 6, and that would be 36. Go a little bit past 6. Your y-axis on your graph. Look at your units. That definitely was the hard. That was a good pick, Jerome, because that was definitely the hardest one on your homework. I see what you're saying.
Would it be right about here?